Hello everyone, today we have an Acer Aspire ZC-606 all-in-one computer. And we push the power button, he does not turn on. Having no screws, I'm pretty sure this thing's just clipped around the side. Seems to be coming apart with a little gentle prying. Has been a while since I opened one of these. But it looks like everything's going to be mounted on the back of the screen, and this is just going to fall off, hopefully. May need to lie it down just to be safe. I've got a feeling I have to pry off the edge of the CD drive, but we'll leave that till last in case we don't. I wouldn't want to break it. Looks like it might go around it. Is there a screw under the foot? Oh look, there's a screw under the foot. How about that? That'll hold you back. Kinda makes sense really. Need a bit more reinforcement than just a few clips. There we go. Ta-da! Nice big shield over the main board there. What have we got holding that on? Looks like a screw there. One up the top. And that looks like it. And then it slides one way or t'other, or just lifts out. No, it just lifts out. Hinges off one side. There we go. Alright, someone's had the BIOS battery out. It's got fingerprints all over it. Looks like there's a bit of flux down here on one of the MOSFETs. It doesn't look factory. It could be. Maybe they just didn't clean it up too well. But otherwise it all looks pretty good overall. So, let's start with the basics. Is it even making it through the DC jack? Or is it as simple as a bad socket? Okay, what we're going to test first is, and I'm using the scope so you guys can see it, instead of having to try and perch a multimeter in view of everything. Here we have our DC jack coming in here. That goes to some inductors, 3 inductors here, and then in through to a little FET under there out to the rest of the board. So I have the power supply plugged in, and let's check on, we'll check on this side of the inductors just to see what's going on. And not a huge amount. I'll just adjust what we're looking at there. We're at 20 volts per division because it's a 19 volt supply. That's now 2 volts per division, and you can see it looks like it's starting to power on and then taper off, and it's reaching about 2 volts as it cycles on and then drops down. So it looks like the power supply is shutting down due to some fault condition. And if we just check the other side of those links, it's the same, so those links are fine. So yeah, something is pulling down the power supply, causing it to shut down and restart. try again. So what's likely to cause a power supply to shut down? Low resistance to ground causing a big overload would do that for sure. So let's chuck our meter on ohms and we'll see if we've got any low resistance to ground there. And we have a dead short to ground. There's 0 ohms between positive and ground, which is the metal chassis. I use a screw head. Anything metal is generally earthed. Generally. So where to from here? Well, it looks like it goes through this large trace here into this FET and through the FET to the rest of the system. So the short could be anywhere, but if the only path through this FET is when the FET is turned on, then the short has to be before this FET. And just having a look, obviously 90% of the time it's going to be a capacitor. And what have we got as far as capacitors across the input? This little one down here, I can see right away. We have a low resistance linking our positive line through to here. Don't know what that does, but it has more than a few separate pins, so it's going to be it's not going to be a FET. Also through a couple of other low resistances, looks like 0.1 ohm perhaps even, there's a couple of capacitors further up. So these get 2 capacitors up here, and then of course anywhere on the other side of the board that it happens to go, because we do have a through hole here, so that could take it that one could take it anywhere. So unless of course there is a short inside the DC jack itself, which I wouldn't be surprised, it could happen. Stranger things have happened. So since I don't have a schematic, I think we'll just start pulling parts off this initial, what we can see here, and get a feel for whether or not we can quickly solve this. Just going to chuck it in diode mode and check across this this FET here and just see what's going on there. Well, if that was working normally, then what I just said would be correct. Our short would be on this side. Turns out this is shorted. Measuring drain to source, dead short. So something has caused this to short internally, and something on the other side of this FET is causing the short and passing through the FET. So this does look like it may have gotten quite warm. It has a funny shading on the top of it. Now we're going to have to try and isolate where that goes and figure out where the short is. The easiest way to do that is probably going to be with heat. And we've got quite a scope to work with. If we're going to inject voltage here, we know that it's normally 19 volts coming through here off the DC charger brick. There's no battery, so it's not a charger as such, but it is basically same as a laptop power supply. And whatever gets hot is going to lead us to the, well, that's probably it. So pull the board out just to be safe. We don't want to get anything too hot in the frame, in the chassis. We'll get rid of the MOSFET first. So if we flip the board over, we'll be looking at these through-hole vias here. They'll be carrying what we're looking for. So they come through to here, but I'm suspecting they're actually part of a much larger inner trace. There's a branch off up to here, but that's I doubt that's going to be what we're looking for. It doesn't seem to go anywhere other than an unpopulated section, so it's not going to be that. So what I've done is connected a wire to the right hand side of the MOSFET, the output side of the MOSFET, so that we can feed through our DC supply some current and look for hot spots, and hopefully there'll just be one. Now because it's a dead short, it's going to take a lot of power to really show up something as a fault. So I've got it at half an amp, and it's only half a volt, just under half a volt to maintain half an amp, so that's not a lot of power. So we're going to need to keep cranking it up. It's going to be a lot of current, but the only way to get the power is to get up the voltage there a bit. So we'll just let it sit there for a little bit and see. Maybe something will start to show up, but I'm thinking we may need a bit more power than that. So a couple of minutes in at 0.8 volts is 1.5 watts, 1.5 amps, and I thought it felt a little bit warm around here, and your lip is a very sensitive tool for measuring temperature. Now, so I used my top lip, and it does feel warm around here. And we do have a couple of capacitors right there, so they're very good candidates, and it does feel like one of those is what's getting warm, so comparatively versus the rest of the board. So I'm going to pull the power off and then take these off and check them and see what we got. Checking the caps for short. That one's okay. Aha! That one's short. Is that our only fault? Let's go back to the input, check on the blue wire. Short is gone. So all we need to do is replace that capacitor, and maybe it'll work. Now we do need to know what value we're putting in here, so if we go to capacitance, and we'll go for the good one because they are both in parallel. So they're both going to be the same value, and this one is get a good probe on it. 20 microfarad, and that'll be at 19 volt rating because that's right on our input line. So we're going to need a 20 microfarad 19 volt cap and another input MOSFET. Remember folks, don't throw anything out. So the MOSFET that I need to replace is a TPC8127 P-channel MOSFET, good for 30 volts and 13 amps. And I have found one on this old board which is, well, 20 volts, no, sorry, 30 volts and max and 12 amps. So that's going to do the job just fine. And it's got two of them, so we have lots of spares. Okie dokie, let's plug it back in. We're back in the chassis, partially assembled, and we'll see what happens. So we'll do a quick voltage measurement to see that it's all coming through the MOSFET and everything's looking promising. So on the output side of the MOSFET, 19.5 volts. And if I probe our front panel connector, we should get some kind of, there we go, 2.8 volts. So that'll be going to our power on button, and that 2.8 volts means that there's some intelligent life now present. So let's see if she'll power on, at least briefly. There we go, the fan is spinning, so it's likely doing something useful. We'll put it back together and have a look at the screen. Right, power on. Acer. And it's booting. What is it? Every time you get a computer to fix, it has to do updates when you first turn it on. It's like the process of updates kills it to start with, maybe. Guaranteed, you've got to wait and wait and wait. Well, that booted up successfully, so there we have it. Another example of how you can find shorts that are overloading your power supplies and so forth. The heat method is the quickest and easiest way to do it. Just got to be sure though that your power supply doesn't exceed the maximum voltage for the rail that you are probing that you're trying to get warm. But yeah, fairly straightforward. Take it easy on the power levels. You don't want to burn yourself, especially if you're using the top lip method. And thanks for watching.